What's up guys, Shawnthebro here, and in today's episode of the Fighting Game Tutorial Series, I want to go over unlockable items in our game. So previously in the series, we covered a store. Now the store is not finished yet, we're still going to be going over more of this in the future. But we could go over and scroll between our items in the store and it would tell us more about it, and then the thought was we would be able to purchase them from here. We have all the functionality working for navigation and currency, but we can't actually unlock the item yet. The button doesn't do anything. So I've added locked icons to everything on here, and these locked icons just represent what we have access to. So right now every single game item is locked because we haven't unlocked anything. As we unlock items, these locks will go away and we can actually purchase them. Or when we purchase them, the locks can go away, depending on if you have characters that need to be unlocked for purchase or if they can just be purchased at any point. Really, the possibilities are endless, but the point is this. We have items in our game that we want to be able to unlock, whether by currency, by purchasing them, or by performing feats in the game. To handle this today, we are going to use the items in our data table that we set up in our unlockable item data. And we're actually going to be able to toggle them as locked or unlocked. That way we can access them if they are unlocked, and we can't access them if they are locked. If you want to get caught up in the series before checking out this episode, you can see all the logic that we've done, from creating our attacks, hitboxes, camera logic, projectiles, and all sorts of fun stuff. Alternatively, if you don't care about that and you just care about the unlockable items, I will recommend you watch this episode right here, which is the first episode of the store. Before watching this episode, if you watch the store episodes, you will know everything and have all the same logic that I do for a lot of the unlockable behavior and unlockable content that we have in our game. With that out of the way, let's go ahead and get started. Now this is a code and blueprint tutorial series, so we are going to be working in the code and the blueprints. However, in today's episode, we're almost exclusively working in the code. We do need a reference to our data table, which is technically in the blueprints or in the content browser, but we're going to start off in the code. We'll get into that in a few minutes. I'm going into my Visual Studio, and I'm going to go to my base game instance.h. My base game instance is where I've done all my saving and loading behavior. The game instance also persists between loading levels and changing maps, so it is a good place to keep track of what the player has unlocked or not. Let's scroll down and let's make sure we have this structure that we're going to need, F unlockable item. F unlockable item is a structure that we made for the store episodes so that we could store all the data about the unlockable item. So the name, the description, the image, the type of the item, the cost of the item, and now I've added a new boolean in here called isUnlocked. This of course represents if the item has been unlocked by the player or not. So everything that was in here that's highlighted right now was already in this structure from previous episodes. The only one I've added is this. So I've made a new boolean called isUnlocked. It is a U property that is edit anywhere and blueprint read write with a category of store. So we will be able to access and edit this in the blueprint. You'll notice that this structure, F unlockable item, has public ftable row base after it, and this means we can actually find this structure in this type when creating a data table in Unreal Engine. So inside the editor, when you're making a data table, you have to select a structure, but not all structures are available. You can either use a blueprint structure or you can use a code structure that has this class marked as the one that our structure is inheriting off of. So F unlockable item is inheriting from ftable row base. Now, since we did this, we were able to go and make a data table, and I'll show you that data table right now. So inside the editor, I can go to my blueprints folder, library BPs, and I have this unlockable item data that we created. You can see in here, I have everything from the index of the row, the name of the item, the description, the image of the item, the type of the item like character stage, outfits, game settings, all that good stuff, and the cost of the item. Now, isUnlocked will be in here, and every one of them should be false. Data tables can't be changed at runtime. They are meant to be read-only, and they're very efficient at that. However, when we add something like isUnlocked in here, we can't change the data of this data table. That's actually okay. The data table itself can say isUnlocked is false for all of these. However, when we go to play the game, we can save out an array of these items and mark them as locked or unlocked, and then save out that result to a file. This will allow developers and other members in a game development team to use a data table to put in information and we'll still allow items and variables to be changed if they need to, such as our isUnlocked column. So I'm just showing you this is what we had. If you added your boolean that I mentioned earlier, isUnlocked, then you'll see this in the data table now. We don't have to do anything with it unless you want to start some of these items out as unlocked by default. Then you could mark them in here, but otherwise just leave them alone. Now I'm going to go back to the code. And now that we've added this boolean, we can make an array that we actually want to use and store all of the unlockable data for. That array is what we can edit and save data out from. Let's scroll down in our logic to where our variables are, and I'm going to make a new one called Unlockables. As it says, it is an array of all the unlockable items and if they have been unlocked or not. So I made a T array of F unlockable item, which is our structure that we were just looking at, and I called it Unlockables. Now additionally, I made this U property of edit anywhere blueprint read write with a category of unlockables. Now we will want this in the blueprint for the store widget at the least, but we will probably also want it for challenges and to determine if we can select certain characters or stages on those respective screens. So having access to this in the blueprints is really important. After we've made this variable, we can go into the base game instance.cpp. Now you have two methods of filling out our unlockables array. The first method is to set them all in the base game instance code or constructor or even another file. One example would be in the base game instance constructor. This logic right here is how I could create and fill out all of the unlockable data within the constructor of the base game instance. I wouldn't need a data table. So I can use my unlockables array called setNum, pass it 1 because there's one item that you can unlock. Then I can fill out all the fields for it. So unlockables index 0 dot name equals, and I called it unlockable item number 1. Then unlockables index 0 dot description equals unlockable item number 1. The image is a little bit more complicated. If you watched the previous episode on news, pop-ups, and patch notes, then this will make a lot of sense. But if not, you can use something called constructor helpers to find objects in the editor in the content browser. And so if we make a new variable, static constructor helpers : F object finder, we need to put in the type that we want to find, and we're going to find a U texture 2D. So that whole big thing is the variable type. The reason we want a U texture 2D is because if we go into base game instance.h and go down to our F unlockable item, you'll notice that the image is of type U texture 2D. So we want to assign it a U texture 2D. This is basically just an image or a texture. If you saw the mannequin image, then that's all you need to know. That's basically what it is. It's just little images in our editor. So this is the type, and then we have to name it just like every other variable. So I've called it unlockable item icon texture. Now in this case, I just went ahead and used the path that I already had of the default level icon. Because I'm not using this method, I'm using the data table method. So I didn't map each of these items out in the code. I'm just showing you that you can do that. If you do use this method, then you need to pass it the path. So after you make your variable, put in parentheses text, and then the path that you want to go to. So I've labeled this as texture 2D because I know that that's the type we're looking for. And then I put a single quote after that to actually start the path. So double quote, texture 2D, single quote. Let's go into our file explorer, and you'll see I have this is my root folder, and I have all of my folders in here. The game folder is actually the content folder. That's where it starts. So if you do /game, it's going to bring you right into this folder right here. From there, you can just go and find the path to the item that you want. So if I want to find the default level icon, I can go to Art, Levels, Default Level Icon. And the U asset is fine, so you don't have to put an extension. You can just say Default Level Icon, and then put a single quote and end the whole thing with a double quote. If you wanted to go to the mannequin, for example, you could go Content, which would be Game, Art, Mannequin, UI Assets, Mannequin Profile Picture. Then after we do this, this will be a valid variable if it was able to find that. Otherwise, it'll be null pointer. So we want to check and see if unlockable item icon texture dot object which basically means, was there an item found at this path, or a file found at this path? And if it was, we can just set the unlockables index0.image equal to the item that was found at that path. Else, that means no item was found at that path, and we want to at least assign unlockables index0.image to something, even if it's null pointer. This way it can be empty instead of just garbage data. So we're going to say equals null pointer. Then finish this up. We have unlockables index0.type equals e unlockable item type : e underscore none. That's just to start out. You could fill it out with an actual value like e underscore character or stage. Unlockable 0.currency cost equals 0, and unlockable 0.isUnlocked equals false. Now this is if you want to set it up in the constructor. I'm using the data table today, but there are plenty of benefits to using the constructor, the base game instance, as well. So feel free to keep this in here if you want. You can comment it out for reference if you'd like, or you can remove it. It doesn't matter. I'm going to remove it. I always will have this video for reference if I need it. That is one very useful method that we have. Now, if you want to use the data table method, since we've already filled out all of our unlockables in the data table, we can do that by going into the init function. In the base game instance init, this is for initialize, we were doing things like checking for controller connection change and calling the load game function. However, we can now actually transfer all the data from a data table into our array that we set up. That way we can track all the unlockable items. We do want to do this before calling load game because the load game is going to overwrite some of the data in here. To do this, we need to get access to the data table, and the data table was made in the editor. So to do that, we need to know the path to the data table. The uDataTable type is one that exists within the code though, so we can call uDataTable pointer and point to the data table that we want. So I've made a uDataTable pointer called Unlockable Data Table. This is going to reference the entire data table and all of its data. We also are going to want an actual path to reference. That way we can use that path to find the data table and then set the item at that path to this unlockable data table variable that we made. Honestly, it's very similar to what we just did in the constructor. We're not in the constructor anymore, so we can't use our constructor helpers. Instead, we can use something called fSoftObjectPath. I call this the unlockable data table path, or unlockable DT path. And I'm going to set this equal to fSoftObjectPath, parentheses text, parentheses, and then the path that we want. So in quotes, I have /game. Remember, that brings us to the content folder. So here is my content folder, and then from here we have to link to our data table. So it was in blueprints, library BPs, unlockable item data. You see, content is game, blueprints is the next folder, library BPs is the third folder, then unlockable item data is the actual name of the asset we're trying to load. Again, we're referencing the U asset. You don't need to put any sort of extension on this. Just leave it like that. At this point, we do need to make sure that an object was found at that path and try to load it. If it wasn't found at that path, it'll fail, so we don't want to use it. Or if for whatever reason it couldn't access that path, it'll fail, and we also don't want to use it. So we're going to set our unlockable data table equal to the unlockable data table path dot try load. Try load will attempt to load the asset at this path. So it's going to take the path, see if we can load it. If it finds an object there, it will return a value, and we can set it to unlockable data table. On its own, we'll just load any uObject. And so uObject is not the same type as our uDataTable. So we do need to put this whole thing into a cast. So we're going to cast to uDataTable, and in parentheses, we're going to put that whole unlockable DT path.tryload. Now, our variable, unlockable data table, will have the value from that result, but we need to check if it's actually valid or if it's garbage data. So we can just check if unlockable data table, and if it's valid, we will go into this if statement. In here, we need to transfer the information from the data table to our array. Remember, data tables can't be edited at runtime, so we can't edit the contents of the data table even though we have a reference to it in the code. But we can pull the information from it and put it into an array. Now, because of the way data tables work, it will only return pointers to each row. So each row in the data table we can grab a pointer to. And because of that, we really need a t-array of our structure pointer. Notice the asterisk here. If you try to make the structure unlockables a pointer, right here, it won't work because t-array of pointers does not work in the blueprints. So what we need to do is make a code-only array, t-array, of our structure pointers, and then make a new array out of it. Don't worry, this array will fall out of scope after this behavior is done and it won't be taking up memory. We're simply going to use it to copy data down from the data table into the array that we actually want. So I've made a new t-array, again, f unlockable item pointer, and I've called it unlockables data. Then we're going to grab our unlockable data table called get all rows on it. And when you do this, it will return the row, but we need to know what type of row it should return. So you see I have the angled brackets f unlockable item. This doesn't have to be a pointer. It knows to put it into a pointer when it's returning it, but f unlockable item is the type. It requires text, essentially the name of each of these items. This doesn't really matter for right now, so I just put in text unlockable item. The other parameter that getAllRows requires is the array that we're returning data into, so that's where we're going to put our unlockables data. This data table will now retrieve all rows and put them into the unlockables data array. At this point, the unlockables data array has all the data from the data table, so we need to take our regular unlockables array, this is the one that we made in the .h file, and we need to make sure it is the same size as the unlockables data. That way we don't run into a crash trying to edit a value in this array that doesn't exist. So unlockables.setNum, and we're going to pass in unlockables data.num. Now our array that we want to keep and our temporary array are the same number of elements. This means we can loop through them and transfer the data. So you see I have transferred the data table to an array. To do this, I have a for loop, standard for loop, so for int I equals 0, I is less than unlockables.num, and ++ I. Then I want to grab my unlockables at index I and set it equal to unlockables data at index I. Remember that unlockables data is full of f unlockable item pointers, so if you try and just set these equal, you'll get an error. But to dereference a pointer, which means you can actually grab the value inside of a pointer, you can put an asterisk in front of the variable. So unlockables I equals asterisk unlockables data I. So we're looping through the full array, grabbing every item from the unlockables data and bringing it into the unlockables array. Quite literally, we are just transferring the data from our temporary array to the array that we actually want to use. Finally, after all that work is done, unlockables will be filled out with all the data from the data table, but now we can actually modify the values if we ever want to or need to. A perfect example and use case of this is the isUnlocked boolean. To wrap up this episode, I really just want to have saving and loading work on this as well. Yes, we have a lot of things that we can do with unlocking, and yes, we need to actually set up unlocking them, setting that boolean to true. But if we know our unlockable items are being stored correctly, this becomes a breeze to do. So the next most important thing is our saving and loading. Let's go to our savegamedata.h. I covered this in my save file episodes, and so we have all the variables from our settings that we wanted to save out, as well as things like our currency. I've added a new item in this class called unlocked items, and I made it a t-array of booleans. Since the data table won't be changing at runtime, there is no reason to save out all the information, all the textures from the unlockable data table. We only need to save out values that will change, such as the isUnlocked boolean. So instead of making a t-array of that entire type, we can just make a t-array of booleans, again called unlocked items, and make it visible in the blueprint. So uProperty, visible anywhere. This means we can access it in the blueprint. We won't actually be able to edit it yet, but we don't need to edit what's being saved out. This is all being handled in the code. It will allow us to see it if we ever need to check it or debug it. Once we have unlocked items in here, you'll notice there's nothing in this savegamedata.cpp for that. You can add something to it if you want. You could set the number. It's not required because none of the elements in the array would actually have any values starting out. So if you'd like to set them, by all means you can. You could say unlocked items.setNum 0. Something like this. Unlocked items.setNum, and we'll say 0. You could do that to set it up, but it's not required. As long as you have this array in here, you'll be good to go. Now, once we have this in here, we can use it to actually save data as well as load data. Let's go into the base game instance.cpp and let's scroll down to our save game function. To this point in the series, we were saving out all of our information in there. And now we need to save out our unlocked items as well. So all the lines I have highlighted here are what we're adding today. Basically, we need to set the number of locked or unlocked values to save. So our unlocked items Boolean array that we just made in the save game data file needs to be set to the same size as our unlockables array, because we want our unlockables array to save out everything that we have unlocked and haven't unlocked. But remember, we just care about the Boolean. So we're going to take the is unlocked from every element in the unlockables array and assign it to an element in our unlocked items array for our saved game data. We're basically doing another transfer from two arrays, just like we did above. So I'm going to grab my data to save and get my unlocked items array. I'm going to type .setNum and then pass in unlockables.num. At this point, we can now transfer over the Boolean value from is unlocked in the unlockables array to our new Boolean array. I'm doing a standard for loop again. Int I equals 0, I is less than unlockables.num, and ++ I. Then we're going to grab data to save, unlocked items at index I, and set it equal to unlockables index I dot is unlocked. I've also added a UE log in here. Log temp warning, meaning that it will appear in the output log as yellow. And I put text in here. Unlockable data has been saved for index %d, which means we can pass a decimal or an integer value to it and it will print the value out with a value of %s. And that means we can pass a string to it and it will print that out. I passed I for the index in the for loop that we're at, as well as the result. But now we've written everything to the save file for all the indices of the unlockable items, which ones are true and false. Now we're going to load them back in the same order. Index 0 is true and index 15 is false. Then we can map those to the corresponding items and know if we have them unlocked or not. Let's scroll down to our load game function, and we need to do the exact opposite of what we just did. So in load game, we need to actually retrieve these values. And to do that, we want to update our unlockables array to have a size of the number of elements that we're loading in. So unlockables.setNum, and this time we're going to say data to load unlocked items.num. So make the unlockables array as big as the unlocked items Boolean array. Then we're doing another for loop to transfer that data one more time. It's going to be for int I equals 0, I is less than data to load unlocked items.num ++ I. You could also use unlockables here, and I think I'm going to. It shouldn't matter, but I think it's just cleaner to write unlockables right there. So I've updated my for loop. Again, shouldn't matter, they should be the same value, but I think it looks nicer that way. Regardless, at this point we now have to do the opposite of what we did, so we need to set unlockables I dot is unlocked equal to the data to load unlocked items at that same index. Then I have another UE log of log temp warning with text unlockable data has been loaded for index %d with a value of %s, also passing an I, and then unlockables I dot is unlocked. At that point we can save and load our unlockable data. There's actually one other thing I would like to do in the base game instance. If you are not using the constructor method and you are using the data table method, I still think we should set the array to have a default number of elements. So I'm going to say unlockables.setNum, and it's okay to put 0 in here because when it loads it's going to update it, but I do think we should give it a default value instead of just not putting it in the constructor. Something I like to set about the load game function here that I did not do before is this setNum line right here. I was setting the unlockables array to the data to load unlocked items in terms of size the first time we load the game. Then the unlocked items that we are loading in from the file will be 0. And so it won't actually set the unlockables array to the right number. So I'm adding this if statement above it where we set the unlockables array to have the same number as the unlocked items if the unlockables array has less items than the data we're loading in. We do this because if we have too little items in our unlockables array, we will crash. However, if we have too many in our unlockables array, it's perfectly fine. We will only fill out the items that the data to load has, so that's not an issue. One other thing I'm going to do is change this variable in the for loop, the .num, to the data to load unlocked items, just because I think it actually is cleaner. After going over this a few times in my head, I think it looks better to do it this way, but really they are the same either way. Just want to let you know why I made that change. At this point, we can play and test out our behavior. Now in the editor, you can open up the output log. The result will print as nulls for the boolean, so the rest of the log should be right. It says that the unlockable data for the proper index is there, but the value is null. I learned this after I implemented it in the code, so in the next episode where we're actually setting the isUnlockBoolean to true and false, I will go ahead and go over this more, but for now we can actually just ignore it. As long as it's printing out the right number of logs for the right number of items, we are good to go. This is for the load, and it should happen as soon as you start up the game. I will now go to the save function, and we'll check that out as well. After finishing my test, the save game did the same thing, so I have changed the log from the data table has been saved at index blank for this value, and just taken away the value. So I just have the unlockable data has been saved for index %d. We will cover the value in the string in the next episode, like I said, when we were actually setting that value. Right now they're all going to be false anyway. I was just doing it as an example. What we want to make sure of is that the output log is also printing the log for saving to the proper indices, so we can see that is being done correctly right here. Then, since we did this for the save game, we also are going to want to do this for the load game. So instead of saying null, it just doesn't print the value right now. We're just going to print out the index and the log, and we'll be good there. We'll know that our logic is working as intended. Now I'll play the editor one more time, and if we look at the log, this is what the load log should look like. Good to go. Anyway guys, that's all I got for you today. Thank you so much for watching. If you enjoyed, please subscribe. It helps the channel out a lot, and I really appreciate it. If you're interested in supporting the channel more, you can check out the Patreon, YouTube membership, or the new Discord subscriptions shown at these links here. And you can see all the rewards if you click that icon in the top right corner right here. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community, and I'd be happy to help you. That is completely free. And like I said guys, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye guys.